Hi, welcome to Data Science Anywhere. In this video, I'm going to show you how to do the document scanner using OpenCV and Python. What I mean to say is that for a given image, something like this, where I'm having the document, more precisely, it's a business card. From this, we're going to extract or we're going to detect the location of the business card, and finally I'm going to use the OpenCV wrap transformation and extract the business card, something like this. However, in order to do this process, it's not pretty straightforward. I'm going to use the OpenCV core concepts like edge detection, morphological transformation, and contours to identify this step, and from there we're going to do the detection, and finally we're going to extract the business card out of this. This technique is not only for the business cards or visiting card, you can also do this technique for what are the kind of document like invoice or any kind of a document can be applied to this. And in the full course of the video, we extend the concept of document scanner and created the beautiful web application developed in Python Flask, where you can choose a file. For example, I can choose this file and you can look into this, and this concept will automatically, if I click on this upload, it will detect the location of the document. And for example, if the location is not perfect, you can even adjust the location, you can even adjust the coordinates, and this was written in the JavaScript. It's completely explained in this course. And once you are ready, or once you have set, and then you can click on the wrap document and extract text, and this will actually do a process and going to extract the text from the document. And not only that, we're going to extract the entities from this. For example, from this business card, I have extracted the phone number, email address, and also some web is also can be extracted with this document scanner app. And in order to access the full course of this document scanner app, you can find the course URL in the description given below. Alright, let's get started with the document scanner in Python. Welcome back. Now let's see how to create the document scanning app. First of all, you need to activate the virtual environment and open the Jupyter notebook. And let's also create one more folder named to document scanner. And let's create all the files in this folder. Anyway, so let's go back to this folder again. And in this folder, I have few images. You can download the images from the resources. And those are all the images. I'm going to work in this section. Let me consider one more image, that is 03.jpg. And you can notice that the business card is rotated in an anti-clockwise direction. All right, let's go back and create a new Python 3. And name it as one document scanner. Okay, the first step what we have to do is that just import all the necessary libraries for the document scanner. Obviously the first one is NumPy as np. Let's also import OpenCV and also import matplotlib.pyplot as plt and import imutils. Execute it. Now let me load one image in the images folder, that is 03.jpg, and this is the image I'm working on. It is highly skewed, and our task is that we need to identify the location and rotate the image. That's what we need to do now. Okay, let's get started. Okay, let's load the image, which is img, and this is what my original image equal to cv2.imread, and just provide the path of this, which is in the images folder, and 03.jpg. Execute it. You can display the two ways. One is with cv2.imshow, and this is my original image, and pass the array, that is image underscore orig. Now cv2.wait key and cv2.destroy all windows. Now execute it. Alright, so this is what the image, and okay, one thing you can notice that we can't fully display the image because the image is too big. In order to display that, we can use a cv2 dot named window, and to which window I just want to provide the resize is the original, and now set the flag which is cv2 dot window normal. Now execute it, and here you go, we have the original image and we can resize this. Okay, so this is what the image that I actually want to transform it. Welcome back. Let's start doing the scanning app. While doing the scanning app, we need to do the two major steps. Step number one is we need to resize our image to the smaller size, but make sure that we need to set the aspect ratio to be constant. And step number two is an image processing is further divided into 7 steps. That is, we need to do the detail enhance, converting image into grayscale, applying the blur using Gaussian blur or average blur, and then we need to use the edge detection techniques and morphological transform, and finding out the blobs using contours, and find out the best 4 points. Okay, without any further ado, let's start it. The first one, what I will do is that let me create the resize function. Let me create a function and name it as resizer, and input to this is image, and let's say width. Let me provide the width is one of the input, and I just want to resize whatever the image I'm having with me into 500. Now based on that, I need to compute the height. That's what exactly I want to do here. In order to do that, the first step what we have to do is we need to get width and height. Okay, so h comma w, and of course we will have the channel information which is c equal to image dot shape. Now the new height is basically height is equal to, based upon my width I need to find out the height. So for that I need to maintain the aspect ratio to be constant. In that case, what I have to do is that I need to find out the aspect ratio which is height by width from the original image, and okay, let's multiply this with width of the image. Okay, so that's it, and with that I can able to get the new height. Now my image equal to cv2 dot resize the image, and input to this is image, and the width and height is going to be width comma height, and finally we will return image comma width and height. Okay, let me do one thing. Let me create the size is equal to this, and let me return the size. Cool, right? Now let's execute it. So with this, what I will do is that for a given any image, we can easily resize this. Let's test this, and we know that this is the very big image, and let me bring that with a width of 100. Let's see what exactly we're going to get here. Okay, so resizer, and the image that I'm passing here is image underscore org, and this is my image re, which is my resize. Now let me display this using cv2.mshow. Of course, this is my image underscore re, and this is my resize. Let me also print image underscore re dot shape. Oh, we got an error. Oh, obviously that we have the two returns here. Let me see the size. In that case, I can just only print the size. Now execute it, and here you go. This is my width is 500, and the height is going to be the 666, and this is what my image. That's really cool, right? You can see that this is the proper size with a width of 500 and the height is equal to 666. You can resize to whatever the width you want, but it is highly recommendable to resize the width less than 500. Okay, so this is how we can resize an image by maintaining same aspect ratio. Now let's move into the step number 2, which is image processing. So the first step what we have to do is enhancing the image. Enhancing image is actually the same as sharpening the image. So OpenCV is actually has a detail enhancing technique is there, and using that we can enhance the image. This detail enhancing will make us to sharpen the image so that it is quite highly useful for the edge detection technique. Okay, so let me take this detail equal to CV2 dot. We have the detail enhancement technique, detail enhance, and here we need to provide the image which is the source, and thus of course my resize image is img_re, and sigma x is actually the size of the standard deviation. You can set whatever you want. I will set this to 20, and the radius sigma r is 0.15. For best sharpening the techniques, it is highly recommendable to use the medium range of sigma s and sigma r. If you increase the sigma x and sigma r, you will image get brighter and brighter and you can't able to see the edges properly. So make sure you set to the proper way, and let's display it. So CV2 dot imshow, and this is my detail, and this is my detail image. CV2 dot weight key set to 0, and CV2 dot destroy all windows. Let me also display my original image. Copy this and paste it here. Now let's see this. So this is what my detail enhancing image, and this is my resize image, original image, and this is my detail enhancing image. What you can notice is that this is really cool, and you can see the edges more clearly compared to this resize image. Cool, right? So, and if you increase the more and more values of sigma, and you can find the more detailed enhancement of this, but too much increment of the sigma x is not a good recommendable method. Okay, let me set to 20, and I'm going to set with the sigma r to 0.15. Try and experiment the different values of sigma x and sigma r, and whichever feels comfortable for you, and you can just go ahead with this. Okay, that's what my step number 1. And the next step is converting the image into grayscale and blur the image. In order to convert the image, I can use this gray, and simply I'll use this CV2 dot convert color, and the input for this is detail. Now set the flag is CV2 dot color underscore BGR, since my image is BGR, and convert to gray, and that's what my grayscale image. Once you convert that image into grayscale, we need to do is blur the image. There are most popular ways of blurring the image. One is the Gaussian blur, and second one is average blur. I will use the Gaussian blur because Gaussian blur will give based upon the weightage and give the more and more blur effect. Okay, let me use CV2 dot Gaussian blur, and the input for this is my gray, and you can set the blur to 5x5 or 7x7, but don't too much blur the image because we want the edges, so don't blur the image too much. The main reason of using this Gaussian blur is to remove all the enhancements whatever we have, and so for that such kind of cases we are using this Gaussian blur. Okay, too much of enhancements, and that's going to be removed using this Gaussian blur. And now set to 0. Done. So with this, what we can get is that we got the Gaussian blur, and finally we will do the edge detection using canny filter. Okay, let's use this edge image equal to cv2 dot canny, and the image input image is obviously the blur, and now set the threshold 1 and threshold 2 is 75, just whatever the pixel values range less than 75, and you just make it to 0, and also more than 200. Let me set this two thresholds, which is 200 and 75. Okay, so this is what the important for me, and now let's display this edge image. I don't want to display all these things. Let me display the edge image. Okay, let me also display cv2.mshow and also display the original image or resize image. This is resize, nothing but image underscore array. Okay, so this is what my resize image, and this is my edge image. What you can notice is that like we have removed all the unnecessary parts. Obviously you can see some kind of a blobs and edges can be found out here, and using the morphological transform we can remove that. But thing is that this is really super cool, right? And let's use the morphological transform and further clean it. Wherever you have the lines, we will enhance it, and wherever we have some dots, some kind of these images, we will close it. Okay, that's what we're going to do using the morphological transform. Okay, morphological transform. Okay, first, in order to define the morphological transform, we need to set the kernel, and kernel you can use any kernel. I'm going to use this 5x5 kernel with all of ones, and 5x5, and change the data type to np.unsigned 8-bit integer. Now let's use this. The first one, what we have to do in the morphological is we need to dilate the edges. So dilate. This dilate will help us to increase the edges intensity. Let's see that. So cv2 dot dilate. Now the input to this is my edge image, and provide the kernel, and the kernel is this kernel. Now set the iterations to 1. If you increase the more and more iterations, you're going to get the thicker line. But let's see that what exactly we're going to get in the dilate. Okay, so now let's also display this dilation, and this is my cv2.resize, and this is my dilation image. Fine, and now let's execute it. And here you go, this is what my edge image, and this is my dilated image. And what you can notice is that we just increase the width of this. If you increase the iterations, if you set this to true, and you will get more and more thickness. Okay, anyway, let's set this to 1. I don't want to increase the intensity of the image too much, so that's the reason I'm going to set this to 1. Now, so we have the dilation, and next thing is that we will close it. Closing equal to cv2 dot, and let's use this morphological x, and here the input to this is going to be the dilation image. Now provide the cv2 dot, set the flag cv2 dot morph close, and the kernel is kernel, and this is my closing image. So let's see what's the difference between the dilation image and the closing image. This is my closing, and this is my dilate image. Let's execute it. Okay, this is the closing image, and this is what my dilation image. So what this closing is going to do is that wherever you find some kind of a gaps, basically the gaps may probably you might get some gap between the two lines, and this closing will help us to close all the gaps. So that's what you can see here. You can note, but in this case it's a pretty clean, and you're not finding any kind of the closing effect. But you can see here is we are able to close all the dots, whatever you have, we can able to close this. right? This is how the things that you need to do in the morphological transform. Alright, so the final step in this process is we need to find out the contours after doing the closing the image. Okay, this is my final step, it is find the contours. You can find out using the contours. Let me take this contours, comma, and obviously we'll get the hierarchy, and that's going to be equal to cv2 dot find contours, and input for this we need to pass the source image, which is the final output, which is nothing but my closing. And after that my mode of operation is cv2 dot ret list, and the method is cv2 dot chain approximation simple. That's it. So this is what I want to do here, and done. Now we can, with this step we can able to find out all the contours, and the next step is that we will sort all the contours based upon the contour area. So you can use the you can sort that contours equal to sorted of contours, comma, and based on what the key is cv2 dot contour area, and set reverse equal to true. So basically we are sorting all the values based upon the descending order. Now for contour in contours, now we will find out the approximate contour. Now peri equal to cv2 dot arc length, set contour, and true. Now approximation, basically this approximate contour is cv2 dot approximate poly dp. Now just we need to draw the line. What exactly we're doing here is that we need to find out the curve, and which is nothing but my contour, and the epsilon, just set the smallest value and multiply with my peri. This is my nothing but my arc length, and closed is equal to true. Now if we found the 4 points in the contours, then we need to break the loop. Okay, so for that let's do the validation. If length of approximation means the number of contour, means number of points we can able to find, is equal to 4, then what I have to do is that I need to break the loop. Of course, first we will take the 4 points equal to, and this is my 4 points is there in the approximate, and obviously this is there in the higher dimension. Let's squeeze it first. Squeeze, and finally break the loop. Done. Now let's draw the contours. You can simply draw the contours with cv2 dot draw contours, and the input to this, to which image I want to draw the contours, is image underscore re, and now provide the contours, which is the 4 points. This is the 4 points in a list, and -1 will fill all the lines. Next is the color which I want to draw is 0, 255, 0, and is 3. Okay, now let's display the image underscore re. This is what my resize image or resize contour image. And now let me also provide this closing image, because that's what the input to the contour. Now execute it. So this is what my closing image, and this is what my resize contour image. You can see that, and this can able to approximately able to find this. And maybe there was some gap, this because maybe probably because of this we have found this. But still, one thing you can notice is that like, oh, this is really clean and this is really perfect and can able to identify the location of the contour. But thing is that this process is still not accurate. In the next lessons we will see the one more level of filtering, and using that we can able to find out what are the mistakes we made in this resize contour, and we can adjust that manually using JavaScript. And that also we will see in the next upcoming lessons. Alright, so this is how we can able to draw the contours. Alright, in the previous lesson we have seen how to identify the contours, and also we drawn the contours for the resize image. But remember, we required the 4 points for the original image, not the resize image. In order to convert the 4 points from the resize image to the original image, what we can do is that we can simply multiply these 4 points with the multiplier, and that multiplier could be the width of the original image divided by the width of the resize image. And the width of the original image can be easily find out from this image underscore ORIG, and if you divide this width divided by the width of the resize image, that is 500, and you can get the multiplier. Okay, so let's find 4 points for original image. Let's first define the multiplier is equal to, and the first thing we need to find out the width of the original image, which is nothing but image underscore ORIG dot shape, and obviously the shape will give you the information about the height, width, and the channel. And the second one, the shape of one, will give you the width, and if you divide this width by the 500, and this information is there in the size, and size of 0 will give you the width of the resize image, so size of 0, and that's going to be our multiplier. Let me remove all these things. Now finally, the 4 points for original image is going to be equal to, let's take this 4 points and multiply this with multiplier, and we can finally get this 4 points for the original image. But here one thing you can notice is that we got the 4 points in the float values. You need to convert these float values into the integer values, so that's what you need to make sure it. In order to do that, let's take these 4 points again and change the data type to integer. Now execute this, and here you go, you got the 4 point values in the integer. And the final step what we have to do is that using these 4 points we need to wrap our image. In order to apply the wrap transform, you can either use the CV2 or I will directly use this IMUtils 4 point transform. Okay, let's import that from IMUtils dot perspective transform, import 4 point transform. Okay, now execute it. Now let's straight away use this 4 point transform of, and obviously we need to pass this image and the points. The image is going to be the original image, and let's provide the original image, and the 4 point is this. Okay, and finally this is what my wrap image. Okay, now what are we waiting for? Let's display it using cv2.mshow, and this is what my wrap image. I think this is wrap. Okay, let's execute this wrap image. Now cv2.mshow. Oh, already we show this image. cv2.wait key and set to 0. cv2.destroy all windows. Now execute it, and here you go. This is what the wrap transform image, whatever we got. It's still not perfect, but we will try to make it perfect in the upcoming lectures. But you can see that with a simple input image we can able to find out the 4 points, and using the 4 points we have bring that into the original image, and this is what the wrap transform what we got. That's really cool, right? In the next lesson we will see more on this. Until then, happy learning. Hey everyone, welcome back. In the previous lesson we have seen how to transform our image. Now let's put all together and create the document scanning function. Okay, let's get started. So what we will do here is that we have the original image is there with us, and the first operation what we perform here is the resize. Let me copy this and paste it here. And also we did all the operations whatever they mentioned here. Let's copy this and paste it here. And the next step is we also did some kind of a 4-point perspective transform. Okay, that's what we did. Now what we will do, let's remove all the unnecessary steps. Obviously this is not required, and the input for this we have the original image. Let me change that into the image, and let me create the function and name it as document scanner, and the input for to this is going to be the image. Now this and all comes inside this. Okay, first step we need to resize it and perform some kind of image processing techniques. And finally we got this cv2.contours, and this we came able to find out the wrap transform for the 4-point transform, and this is basically trying to finding out the 4-point for the original image. And finally we wrap the image. This wrap image is actually the cropped image. Okay, and now what I will do, I'll return the wrap image and 4 points. So the two things I'm just going to return here. Obviously to be honest, I really don't want to return this, but in the upcoming lectures what you're going to see is that we are going to use this 4-point transform and trying to correct our wrong predictions, because this will not work for all kinds of images, because there are lots of assumptions are there in this. We will see in the next lecture that for what kind of scenarios this function is going to fail, and keeping those things in mind we will see how to approximate in the upcoming lectures. Now execute it, and finally we have the document scanner is there with us, and input to this is going to be my image. Let's see, let's do it from the starting, and let's say this is what my image, and let's read the image cv2.mread, and the name of the image is in the images folder, and it is 03.jpg. and now we will find out all the document scanning applications, everything is there. We take this document scanner, and what we will do is we are going to pass this input image img, and this is what my wrap image, and this is my 4-point. That's going to be equal to this. Let me do one thing, let me also provide the contours, because that will give you the much more better information, and the contour information is actually there in the resize image. And also let's provide the closing information too. For the time being, let's take this just for the sake of analysis, and obviously in the while doing all the predictions and all, we are not going to use all these things, but here for analysis let's do this. Okay, this is what my resize image, or you can say contour image, and this is my edge image. Okay, now execute it, and here you go, we have all these things are done. Now let's see cv2.mshow. the first one is what my original image img, this is the original image, and img. Next is cv2.mshow. let's display the resize image, and remember this resize image is also contains our contour information. It's nothing but this. Next, let me display the edge image. Next, let me display wrap image. Next is cv2.weight key, set to 0. Now cv2.destroy all windows. Now execute it, and here you go, this is what my original image, And this is what my resize image. And what else we have? Only two. Oh, we have all these things. So resize, let me change the name. This is resize, and this is edge, and this is wrap. I execute it. Yes, that's cool. This is my original image, and we resize this into, let me open. Okay, this is the image. Yeah, this is the resize image, and obviously this is my edge image, and this is what the transform we can able to get here. Okay, so this is what we can able to do in the step-by-step process on how to able to extract all kind of a document scanning app. So this is what a simple process which can be used to scan the document. Let me test this for one more image. Let's say I'm having the few more images with me. Let me consider this is 000.jpg. Let me change this as 001.jpg. And now, so this is what my original image, that's correct. And this is my resize image, that's correct. And this is my edge image. Oh, wrap image, we got some kind of wrong assumptions. Let's go back and see what exactly is happening. Yeah, the thing is that this is what the image, I need to pass it to here. We need to transform this, and of course this is my image underscore re. I need to also replace this, and let's see wherever you find like image underscore img, we need to replace this with so I don't find anything. Okay, that's fine, that's really good. This is cool. Now you can see that this is what we have, and this is the one, and this is the one. This is really cool. Now here you go, you can see that this is my original image, and resize image, edge image, and this is my wrap image. Cool, right? Let me also do for one more thing. This time I'll go for 003.jpg. This is a 003.jpg. In this case the background is a bit cluttered, but let's see how exactly we can able to work with this. Okay, let me zoom it again. This is 33.jpg. Execute it and execute it. Okay, this is also working, and this is my resize image. This is my original image of this is my resize image, and it works really fine. Our contour can able to find out the edges properly, and this is what exactly it's happened here. And this is what my wrap image, and that's also really cool. Cool, right? So this is how we can able to do simple document scanning app. In the next lesson, we will see more on this. Until then, happy learning. And in the full course of the video, we extend the concept of document scanner and created the beautiful web application developed in Python Flask, where you can choose a file. For example, I can choose this file, and you can look into this, and this concept will automatically, if I click on this upload, it will detect the location of the document. And for example, if the location is not perfect, you can even adjust the location, you can even adjust the coordinates, and this was written in the JavaScript. It's completely explained in this course. And once you are ready, or once you have set, and then you can click on the wrap document and extract text, and this will actually do a process and going to extract the text from the document. And not only that, we're going to extract the entities from this. For example, from this business card, I have extracted the phone number, email address, and also some web is also can be extracted with this document scanner app.